Welcome to the first chapter of the course, and this chapter is specially designed for motor control. So we will cover all theoretical and practical aspects of the motor control. So eventually we will be able to control the velocity of a motor using STM32 microcontroller. So in this chapter, we will start um, discussing like the basic topics about the motor control. Then we will cover different motor drivers. Then we will switch to practical exercises. So we will learn how to generate pulse width modulation signal using STM32 microcontrollers. And in addition, we will cover timer encoder mode, which allow us to read the velocity of a motor. Then we will cover moving average filter. Then we will finalize this chapter covering PID controller. So in this chapter, you will learn a lot of things, not only related to the motor, but also STM32 programming and related to robotics. So enough words, let's get started. So let's start from basics. So in the market, if you search for a web, you can find a different kind of motors. But in robotic applications, we usually have three types of motors. So the first motor is a DC motor. So I have a few of them. For example, here I have very tiny DC motor. Then I have a bigger one, for example, just over here. And this DC motor is usually used in small scale vehicles in simple robotic applications. Then we have the second motor. We call it a second type of a motor, which we call brushless DC motor. Usually you find these motors in drones, in quadcopters. They're pretty good to generate high torque at a high velocity. And the final type and finally we have stepper motors. They are really good at providing precise position. That's why we usually find stepper motors in CNC machines, in 3D printers. And in our project, in designing the balancing robot, we will mostly use a DC motor because it's simple to control them. But later I can also show how to use stepper motors as well. So as I said, we will use a DC motor. So let's talk about the internal structure of the DC motors. So inside of a DC motor, where we have these magnets as the static part of the motor. And inside of it, we have these coils. And I think the key part of the motor, of the DC motors, is these we call it brushes and commutators. So this brush, this wire, is basically touching the. So this is for example, commutator. Then we have a brush, which is basically touching the rotor, but it's not fully fixed. So the rotor can still rotate, but brush is always in contact with the rotor. So what we have is that when we apply voltage to these wires, basically to these brushes that are like touching the rotor, what we have voltage applied to these coils, and it will create a magnetic field. And this magnetic field will interact with the magnetic field of magnets. So they interact with each other. That's why the rotor starts rotating. As simple as it is. And of course, on the web, you can find even more detailed information about the internal structure of the motors. And of course, you can find many types of videos on YouTube and other platforms. And next, let's talk about basic principles. So when we talk about motors, we usually have two key parameters. First parameter is we call it rotational speed, which basically defines how fast a motor is rotating. And in practical cases, we usually use rotation per minute unit. Okay, so if it rotates 60 times per minute, we have 60 times RPM, 60 RPM. But in physics, like in modeling motors, we usually use radians per second unit. So this is like standard SI unit. And the question is, how can we convert? So if we have RPM, how can we convert it into radians per second? Can you guess how it works? I hope you know the answer, but let me just consider a simple example. Imagine that you have a motor that rotates 60 times per minute, 60 RPM. So first, let's find the rotation per second. So we divide by 60. So it means that it does one rotation per second. And one rotation, as you remember from basic trigonometry, one rotation is 2 pi, which is 6.28. So 60 rotation per minute is equal to one rotation per second, which is around 6.28 radians per second, 2 pi per second. And the second parameter is torque. So what is torque? Torque is basically rotational force that a motor can generate, or something which is resisting the rotation. The quite obvious analogy to torque is force. So imagine that you have an object, and in order to move it, you need to exert some force. Okay. And also there might be some force which will resist the movement, which for example could be friction. So if you have like an object on the surface, and if you push it, of course we have some friction which will impede the movement. And in a similar way, when we have the rotation, first we have a motor which generates some torque to handle rotation, but we also have some resisting torque, which also could be friction. For example, I have a motor, like I have a wheel which is rotating, but if I put it on the surface, of course we have some friction which will generate some torque. So this is the equation, like the classical equation of the torque. So we have a force multiplied by the distance between the point where the force is exerted and the axis of rotation, and also we need to consider an angle between them. That's how it works. So we have this equation, but for us it is quite important to intuitively understand these equations, not just to memorize it. So we need to internalize all these concepts. So to do that, I'm going to provide you with a simple example. So here I have a 1 kilo mass, and so right now I will hold like that. So let me put my microphone closer. So I'm holding like that. So what we have, due to the gravity, it will try to, so this mass will create some torque to rotate my hand. So what I have to do, I have to stretch my muscles to keep it upright. So my muscles will generate resisting torque to keep this object in this position. So what I can do, I can take another mass. So in that case, I have 2 kilo mass. And if I do like that, for me, it's more difficult to hold like that, because this mass is like 2 times, so this has 2 times higher mass than the object that I used before. So for me, it's harder to keep it upright. And the question is, how can I decrease the torque keeping this object? So of course, what I can do, I can put this object closer to my shoulder by the axis of rotation. So this distance is less, and based on these equations, it generates less torque. So for me, uh, it is easier for me to hold that object like that. But if I extend, I am increasing the distance, and it will be quite difficult to keep in this position. And I think it's a nice exercise. Another way, if we consider this sine theta, so instead of keeping like that, so we have so we have 90 degrees, so sine theta will be equal to 1. I can hold like that, and then I have this angle, so we have again less torque. So I hope this concept is clear for you, and of course, if you have any questions, you can drop a comment in the discussion section of this video. So we know two basic concepts: torque and the rotational speed, let's say velocity. Next thing we have to talk about this torque speed curve. So this is essential concept in motor control. So I ask you to listen all of this carefully. Okay. So this so in motor control, torque and speed are related to each other. Okay, they don't exist independently. They always depend on each other. And this torque speed curve basically shows the relation between them. Okay, so for example, when we have zero torque, we have this speed, but once we increase the torque, we just travel along this line. So this shows how torque and speed are related to each other. So again, to explain how all this works, again, I have a motor, and what I do, I would just connect it to some battery. So it's rotating, as you see. So here I don't have any torque, resisting torque. So can you find this case like a point in this curve? Hope you can find that point. This case is this region. So we have no resisting torque. That's why we get the maximum speed. So we around here, okay, around no load speed. But once I apply some friction, it will create some torque, of course. And due to that, we have less speed. So what will happen in that case? We will just travel along this curve. So if I apply more and more friction, we have more and more resisting torque. That's why we have less and less speed. And what would happen that if I apply this amount of torque, our speed will be around here. So we just need to do projection, and here we find we have this speed, of course. If I apply more torque, and at some point we reach this critical point, so we have zero speed, and we have the maximum torque that motor can produce. And in this case, we call it stall torque. Next, as you noticed, is that when we work with motors in robotic applications, we usually find a gearbox. So gearbox is yeah, I can show you one like a gearbox I have. So it's a set of gears connected to the motor. Also inside of toys and the other like like robotic devices usually find like a gears inside. And can you guess why we need this gearbox? So the problem here is that if we don't use a gearbox, we usually have this torque speed curve plotted by this blue line. So we can generate a lot of like velocity using the motor, but we have little torque it can withstand. So once we apply a little torque, the based on this curve, for example, if I apply this torque, what we have this speed. And what would happen? We have little speed. So just barely touching the motor, I can just stop it rotating. So what it means is that if we apply the motor without using the gearbox, it is usually useless. There is no much torque it can generate. But once we use a gearbox with the motor, what will happen? We just change this motor speed, torque speed curve. We modulate it. So what would happen is that instead of having this speed curve, we get this red line. So what will happen is that we can of course unfortunately generate less speed, but we have a lot of torque. So here, for example, I show this point. So if I apply this torque, instead of getting just this speed, if we have this line, what we have, if we do the projection, we have this speed. You see the advantage of the gearbox. So having this gearbox allows us to create a lot of torque. And that's why we can install a wheel, we can design some device, like some moving device using the gearbox. That's why it is quite essential to have a motor with the gearbox. So here I have the smaller one, and for example here I have the motor again, and this part is basically gearbox as well.